Nature can ruin your life with a tsunami, hurricane, tornado, rainstorm, and many other destructive events. But did you know that it also has other, weirder ways to destroy? Let's take a look at the most unusual natural phenomena. How about the orange rain? It's not that orange drops are falling on you, no, the whole sky and the atmosphere are turning dark orange. Orange clouds are pouring dirty orange drops on you. Don't worry, they're not poisonous, but watch your eyes. Don't let the drops get in because they contain sand particles. If you want to see this unusual phenomenon, go to the Canary Islands. Every year, the sky turns orange there and pours orange-red drops of water mixed with sand onto the ground. This phenomenon happens because of the Sahara. In the desert, strong winds blow millions of tons of dust and sand into the air. All this mess penetrates the atmosphere and turns the sky orange. Then, the particles from the Sahara fly toward the Canary Islands and fall on people in the form of heavy rain. Residents of this region experience breathing problems and poor vision in the orange conditions. Airports stop working. All flights are canceled. Under favorable conditions, a storm that carries sand particles can reach both the Mediterranean and northern Europe. Therefore, if you suddenly see red rain, don't be scared. This is not the apocalypse. Warning: this kind of rain causes anxiety. During this phenomenon, you won't see drops of water. There will be spiders falling from the sky. People have faced spider rains in Australia, the United States, and the United Kingdom. These creatures are called money spiders, or sheet web weavers. During strong winds, they climb as high as possible to the tops of plants, bushes, and fences. Then, they release a parachute-shaped web, and the wind blows them into the sky. They fly high into the air, meeting birds, cold winds, and harsh weather. Not everyone can survive this journey. Then, when the weather calms down, this tiny party lands on the ground. No one knows why spiders behave this way. According to one version, they fly away from places where flooding can begin. In other words, it's a forced migration. And because of this migration, spiders often become the first settlers of territories that have been destroyed by fires or other natural phenomena. But don't worry, these creatures are harmless to humans. They just want to live and multiply. Although, to be honest, it's hard to stay calm when thousands of arthropods are falling on your head. Tornadoes are a destructive force. But look at this. A whirlwind appears during a snowstorm. It's sucking in more and more snow. Now, it's not just a tornado, but a snow-nado. It looks like something terrible and destructive, but don't worry, it's not as scary as it seems. This is a fairly rare disaster that has recently occurred in Utah. The snow tornado came across a man and his dog on its way. It looked impressive and dangerous. Fortunately, no one got hurt. This phenomenon occurs when an air vortex raises snow from the ground. If you see a similar vortex next to you, don't panic. Usually, such phenomena are harmless and don't have enough force to destroy things. This natural phenomenon is much more dangerous than the snow-nado. Just imagine that a mountain of chunks of ice is moving along roads, sweeping away everything in its path. It looks like a tsunami, but instead of water, there are ice boulders. The ice tsunami can destroy houses, cars, and trees. It can move on grass, asphalt, and sand. It can jump out of the water like a crazy salmon. Fortunately, the ice tsunami is not a frequent phenomenon. It occurs when three conditions are met: a flat coast, loose ice, and strong wind. Waves and wind are throwing broken pieces of ice onto the shore. These ice flows accumulate into a huge wall, and then, during strong winds, this ice monster begins to move. Therefore, if you see a large pile of ice near the water, move away from this place as far as possible. And we're back to the tornado again. You already know about snow tornadoes. You've probably seen the footage of tornadoes in a desert when the wind blows sand into the air in documentaries. Tornadoes pass over the ocean's surface and can create a funnel inside the water. But there's a phenomenon that's even cooler and more impressive. It's a fire tornado. Surely not many of you have heard about this thing. It's a very dangerous phenomenon. but people have ventured close to the fiery tornado to study it. But firefighters, by the way, often encounter this devastating phenomenon. A fire tornado forms during forest fires, and sometimes it can appear inside a burning building. If you see a big flame and feel a strong wind, be careful. A fiery funnel may form. But how does this happen? Let's first look at the origin of an ordinary tornado. So, we're somewhere in a dry place in the middle of a hot day. The sun heats the air that is close to the ground. Its lower layers absorb more energy than the upper ones. An increase in temperature makes this air less dense and more buoyant. Then it lifts into the sky in the form of long columns. This rise has a spiral movement. The water in your bathtub moves similarly when it flows through the drain hole. So many of these air vortices are quite weak, and you can't see them. But some of them encounter strong air currents. This accelerates their movement, adds energy, and increases the area. More and more air gets into this vortex, making it stronger. When dust and sand get into these whirlwinds, you see a tornado. The fire tornado follows the same pattern, with only one difference. The air below is heated, not by the sun, but by fire. Fire heats the air, it rises, rotates, and pulls the fire inside. Some of the vortices can reach up to 400 feet high and 50 feet wide. It's like a thin, leaning tower of Pisa made of fire, only twice as tall. This is a truly devastating and terrifying phenomenon. The ground is shaking. Flocks of birds are flying away. You can hear a loud, low rumble. The volcano spits out a giant ash cloud. Lava is flowing from the mouth of the fiery mountain. Rivers of fire are running down and dashing towards you. You have nowhere to escape. The fire is getting closer and closer, and wait a minute. This lava isn't hot. It's cold. How is that possible? You can observe cold lava flows near many volcanoes. In Indonesia, for example, this phenomenon has recently destroyed entire villages. Yes, it's not hot, but it's still dangerous. Cold lava streams occur when hot lava mixes with ash, sand, and pebbles during wet weather. In a sense, the volcano spews out streams of heavy mud. It covers roads, houses, cars, and trees. Cold lava flows are a destructive phenomenon, so stay away from them. Even if some volcano is very beautiful and you want to take cool photos, don't take any chances. Okay, let's relax a little and end our video with something fun. How about surfing? But instead of ordinary waves, we have icy ones. This phenomenon is called the ice wave. It looks as if someone paused a wave while it was forming before it hit the water. It's a rare occurrence, but you can find it on Mount Washington. The top of the mountain is shrouded in fog most of the year. Cold temperatures, humidity, and winds form frost. Then strong winds force this frost sideways, and thus a wavy shape forms. And when there's a wave, you can ski or snowboard inside, like a surfboard. But be careful, it's pretty cold in there, so wear warm clothes. If you were visiting Earth from another planet, your rational mind just wouldn't understand how singing dunes and moving balls of lightning were scientifically possible. I bet you'll feel like these images are just stills from your favorite sci-fi movie. You better hope you never find yourself alone near Catatumbo River in Venezuela during one of its lightning storms. Because if you were, you'd be surprised to find out that lightning works both ways, meaning it can come from the sky and from the ground. Terrifying, I know. Scientists think that in this case, it probably happens because of a high presence of uranium in the bedrock. But it can also happen due to cold and warm air currents that meet around that area. This makes the electric field get all charged up and the bolt flips, traveling from ground to cloud. Scientists even have a fancy name for it: upward lightning. This special place called Catatumbo River became famous because of its light shows. Actually, the name means House of Thunder in the local language. This phenomenon happens for up to 160 nights a year, and it can last around 9 hours a day. When scientists counted, they realized that the area could produce anything from 16 to 40 flashes of lightning per minute. Now, you've probably heard of Marco Polo, the 13th century Venetian merchant and world traveler. Well, in one of his voyages, he came across what he could only describe as singing dunes. The dunes literally started rumbling, like they were playing drums, and freaked him out so much he thought it was the works of evil, invisible entities messing with him. Fast forward to our times, and scientists have discovered how sand dunes produce these rumbles. A team of scientists studied a singing dune in Morocco. They chose a large, crescent-shaped one that makes noise all year round. If the wind is right, this dune can sing a few times every afternoon. It turns out that the wind forces sand to accumulate at the top of the dune until the angle of the slope reaches a tipping point of about 35 degrees. This accumulated sand drops down like an avalanche, and that's what produces a sound. The sand needs to be dry enough for the singing to happen, though. They're like nature's boombox. Isn't that something? This next one might be the most disturbing of them all. First, you'll see a flash of lightning, then a thundering boom, and finally, a curious light floating through the air and bouncing off surfaces like a white electric ball. Would you also hide under your blanket if you witnessed something like this? That's what an old lady did when she witnessed this from bed in her Chicago apartment. It turns out, people have been swapping their own ball lightning stories for hundreds of years. An English monk's report from the early 1000s might be the oldest version of these accounts. It talks about a fiery globe descending from a storm cloud and falling into the river Thames. The thing is, scientists aren't entirely sure what causes it. But one theory involves lightning striking silica-rich soil. This can vaporize silica, creating tiny particles bound by electrical charges. When these particles react with oxygen, they produce glowing orbs, which can last a few seconds. Some other theories say that it can be linked to miniature black holes, or even hallucinations. But the silica explanation is the best contender so far. What they know for sure is that ball lightning is often linked to stormy weather. If you'd wake up in the middle of a wintry night and saw these lights, you'd probably think otherworldly people were invading our world. Or you'd feel like one of the lucky people who got to see the northern lights during your lifetime. But none are correct. These beautiful shafts of pastel-colored light were photographed by a guy in Ontario, Canada. They happen when tiny, flat ice crystals that usually reside up in the atmosphere float closer to the ground. They're sometimes called columns of violet light, and they reflect light from sources like streetlights or cars. These reflections stretch into tall, colorful columns that look like they're glowing in the sky. The best part is that it's mostly an optical illusion. The pillars aren't really in the air. They're just a trick of light bouncing off the ice. Somewhere near Buffalo, New York, you'll find a surreal combination of the fire and water elements. This phenomenon is called the Eternal Flame Falls, precisely because it never stops burning, even if it's so near the water. This is due to a chemical reaction where gas leaks out of the ground and combusts with the air. It's one out of a few hundred natural eternal flames around the world. But the 30 feet tall waterfall is probably the most beautiful one. Now, how does it get lit the first time around? Usually, eternal flames can be ignited by lightning, human activity, or something called piezoelectricity, which is basically when certain materials make electricity when you squeeze, press, or twist them. Scientists believe that Native Americans lit these flames thousands of years ago, but that's just a hunch. Have you ever imagined going for a midnight swim and suddenly finding yourself surrounded by a glowing blue haze? As if there were huge cannons of light coming out of the seabed directly into the surface. This phenomenon is rare, but it sure is magical. This chemical reaction is known as bioluminescence, and it can happen in different situations. One example is when tiny algae organisms migrate near the seashores. When these algae are disturbed, they try to defend themselves by glowing and just happen to create the most beautiful spectacle. There's also a specific place in the world where you can see a similar phenomenon. It's in New Zealand. Hidden deep within the country's caves lie the so-called glowworms. They are the larval species of a fungus that happen to be luminescent. If you're lucky enough to tour around these caves, you'll feel like you're floating inside an underground galaxy. The sky can create lots of different cool phenomena, and this specific one is called a crown flash. If you were seeing it with your own eyes, you'd see a column of light jumping or dancing near the top of a cumulus nimbus cloud. Think of cumulus nimbus as massive, towering clouds that look like fluffy mountains. These are the clouds that usually announce thunderstorms, lightning, and heavy rain. Now, although you'd probably think crown flashes looked like some supernatural energetic door opening to the heavens, this is a very scientific phenomenon. It happens when sunlight reflects off tiny ice crystals inside the cloud. But here's the cool part. Those ice crystals aren't just floating around randomly. They're moving because of shifts in the cloud's electric field. As the field changes, the ice crystals realign, and the light they reflect moves too. That's why the crown flash looks like it's flickering or waving. Crown flashes don't happen all the time. You need a thundercloud with the right conditions, lots of sunlight, ice crystals, and a strong electric field. If you ever spot one, consider yourself lucky. It's like nature showing off a rare light trick. We usually see ever-burning hills in sci-fi movies, but this one is real. Located in the Arctic region of Canada, the so-called Smoking Hills is an unmatched sight on our planet. And here, things get even a little science fiction-y, since some minerals that exist in these hills were only ever found in a few places on our planet and outside it, like on the surface of Mars. The ground of Smoking Hills has been releasing smoke for at least a couple hundred years, non-stop. Explorers thought the area was home to an active volcano, but that was not the case. As science explains, the soil in the area is formed by sulfur and coal, and when they're in contact with oxygen, they spontaneously ignite, releasing constant smoke. I just warn you, don't be getting any touristic ideas. The environment is extremely hostile to human life, as the smoke is toxic and its temperatures are dangerously high.
So in Westbrook, Maine, people saw an enormous ice disk in January 2019. This disk was like a wintry carousel. It was spinning away in the Penobscot River. Residents called it everything from an icy lazy Susan to a frozen spinning wheel. It was estimated to be around 300 feet wide, which made it one of the biggest ice disks ever seen. Weirdly, the spinning ice disk notion isn't new. They've shown up in places like Russia and Washington before. They were almost always a perfect circle. So why do they happen? Well, some scientists in 1997 thought it was because river water created a whirlpool effect around a chunk of ice, smoothing it out to be perfectly circular. Yet, in 2016, other scientists claimed that river currents helped these disks get started, but temperature changes kept them twirling. Warmer water makes the ice melt and sink, creating a vortex that keeps the disk spinning. The warmer the water, the faster it spins. Ever heard of the Hestilin lights of Norway? They aren't the same as northern lights. Think of these lights as glowing balls. They have been seen since at least the 1930s. These luminous wonders show up in all sorts of colors and shapes. Sometimes they flicker, and other times they just chill in the air. The Hestilin lights can show up 10 to 20 times a week. They appear both during the day and at night. They can last for just a few seconds or hover for over an hour. Interestingly, nobody has a clue about what exactly they are. The efforts to understand these lights include Project Hestilin, started in 1983, and later projects like the Triangle Project. Despite ongoing research, there's no consensus on the origin of the lights. Some suggested explanations include misperception of celestial bodies, aircraft, or mirages. One theory ties the lights to airborne dust from mining, while another mentions plasma, formed by ionized air and dust during radon decay. Okay. Ringing rocks is a cool geological thing you probably didn't know about, and it's our next stop on the Mysterious Natural Phenomena Tour. You can find them in Bucks County in the U.S. If you give these rocks a hit with a hammer or another rock, they start ringing. Scientists have been studying them, but the mystery remains. There are different hypotheses about this one too. Things like the size and shape of the boulders and how they're stacked can affect the sounds they make. But that alone doesn't give them the ability to ring. Even though the sound is often described as metallic, it's likely because of the rock's density and internal stress, not just its iron content. A scientific experiment from the 1960s suggested that the ringing ability came from some internal stress, not external weathering. The live rocks found in the middle of boulder fields showed expansion or relaxation after being cut, indicating internal elastic stresses. A slow weathering rate in dry fields could cause these stresses. The relic stress theory suggests that these boulders act like guitar strings. A de-stressed boulder gives a dull thud, but a stressed one resonates at different frequencies. The boulders can still ring when removed from their fields, leading to myths about stealing them. Most fields are now cleared of smaller ringers, and breaking large boulders stops the ringing. Large equipment is needed to move the remaining small ringers, weighing over a ton. Now let's talk about the Naga fireballs. They only show up along the Mekong River in Asia. These picky fireballs hang out in just a 155-mile stretch of the river. The reddish glowing balls rise naturally from the water into the air. Their scope ranges from small particles to the size of a basketball. The reported number of fireballs varies from tens to thousands per night. They can be spotted all year round, but they seem to go wild during the full moon in late autumn. Why? Well, that's just another one of their little mysteries. Some have tried to explain the phenomenon scientifically. One theory suggests that flammable phosphine gas from the marshy environment could be the cause. However, skeptics argue that spontaneous ignition isn't likely to be the reason. Another scientific explanation involves free-floating plasma orbs created when surface electricity is discharged into a solution. Still, these typically occur in controlled settings during experiments, and not naturally. We can carry on with ball lightning. It's a super rare thing, a glowing ball that shows up in the air. It likes to make an appearance close to the ground during thunderstorms, hanging out with regular lightning. It can be red, orange, yellow, white, or blue, and it's often accompanied by a hissing sound and a funky smell. This flashy sphere of light is a quick show. It lasts just a few seconds, zooming around, and then poof! It's gone, sometimes quietly, sometimes with a little pop. Ball lightning might seem like a troublemaker, but it's usually harmless. Sure, it's been known to burn or melt stuff on occasion, but it's not out to get us. Scientists aren't entirely sure why it happens or how it's related to regular lightning. People have been tossing around ideas like weird air or gas behavior, high-density plasma stuff, or even a vortex of glowing gases. Even microwave radiation trapped in a plasma bubble is on the list. But don't get it confused with bead lightning. That's a different one, more like a string of beads. And it happens when a bolt of lightning sticks around for a good chunk of a second. Shh! We're now at the Mapimi Silent Zone. It's this spot near this place in Mexico. The story goes that in this desert patch, you can't pick up any radio signals or talk to anyone. In July 1970, a rocket from Utah went off course and landed here. It was carrying some sort of cobalt. Authorities had to haul away tons of soil from the crash site. Now, thanks to the cleanup, the Silent Zone is wrapped up in myths. People talk about weird magnetic stuff messing with radios and about plants and critters going through mutations. Well, locals go with it, boosting tourism in the region. Alright, we can now talk a bit about the sun. Well, it's not just a big ball of fire. It's got an outer layer called the corona. Think of it as an invisible sun jacket made of gases. You usually can't see it because the sun is super bright. But there's a trick. During a total solar eclipse, when the moon slides between us and the sun, the corona shows up, all glowing and white. The corona is scorching hot, even hotter than the sun's surface, which is kinda weird. Scientists are on a mission to crack this heat mystery. They found something called heat bombs shooting from the sun into the corona, exploding and warming things up even more. But that might be just one piece of the puzzle. You see, the sun's surface is like a playground covered in magnetic fields. These magnetic fields create cool shapes on the sun, like loops and streamers. Special telescopes help us see these cool patterns up close. The corona stretches way out into space, and from there, it sends out the solar wind that moves through our solar system. Its particles are so speedy that they escape the sun's gravity. So, there's this cool spot called Kuala Sangalore Beach that you can only check out when the tide is low. The timing changes every day, and you can't get there when the tide is high. Most of the time, it's hiding under the sea, not even on the map. But when the tide's just right, bam, it pops up. Kind of like Malaysia's own version of Salar de Uyuni. People call it the mirror of the sky, because when it's not underwater, it turns into a giant reflection of the sky. An awesome spot for cool Instapics. Besides being a sweet travel spot, it's also home to a bunch of marine life, like sea and baby clams that live all over the sandy shores.
Welcome to our podcast, where the mysteries of our planet come alive and the wonders of nature are unraveled. Today, we embark on a journey that dives deep into the depths of the Baltic Sea, sails through the treacherous maelstroms, and gazes up at the towering might of volcanoes. From the enigmatic Baltic Sea anomaly that has puzzled many to the awe-inspiring phenomena of square waves and tidal bores, we'll explore the captivating tales of Earth's marvels. Whether it's the mesmerizing dance of underwater black holes or the fleeting beauty of the green flash at sunset, our planet never ceases to amaze. So sit back, relax, and let's set sail on this voyage of discovery, where science meets storytelling. In 2011, a team of divers, driven by the allure of hidden treasures, ventured into the depths of the Baltic Sea. But instead of gold or ancient shipwrecks, they stumbled upon something far more perplexing. An object so unusual, so out of place, that it seemed to defy all logic and reason. The photographs they captured of this anomaly sent ripples of excitement and speculation across the world. Was it a relic from an ancient civilization? A sunken spaceship, perhaps, from a galaxy far, far away? Or maybe a natural formation, shaped by forces we are yet to understand? While some believed it to be remnants from extraterrestrial visitors, others theorized that it might be a phenomenon from the Ice Age, possibly even a meteorite that had been trapped under layers of ice for millennia. The metals detected within this structure were unlike anything that could form naturally, adding yet another layer of mystery to the enigma. As we navigate the waters of intrigue surrounding the Baltic Sea anomaly, it's impossible not to be drawn into the whirlpool of theories that have emerged in its wake. The enigma has become a magnet for both scientific scrutiny and wild speculation. So, what are the prevailing theories that have tried to shed light on this underwater mystery? First and foremost, there's the extraterrestrial hypothesis. The peculiar shape and composition of the anomaly led many to believe that it might be a crashed UFO, a remnant of an advanced civilization from the stars. Its almost perfect oval shape and the strange patterns on its surface have been likened to depictions of flying saucers in popular culture. Could it be possible that this is evidence of a visitation from beyond our planet? Then there's the historical angle. Some experts suggest that the anomaly could be a relic from World War II, perhaps a sunken submarine or an ancient shipwreck. The Baltic Sea, with its tumultuous history, has been the final resting place for countless vessels over the centuries. Could the anomaly be one such vessel, its story lost to the sands of time? Another theory, grounded in natural science, posits that the anomaly could be a unique geological formation. The Baltic Sea has a rich geological history, and the anomaly could be the result of glacial movements from the last ice age. Some even suggest it might be a meteorite, a fragment from space that collided with Earth thousands of years ago, now lying dormant beneath the waves. But with every theory comes a counter-theory, and for every answer, more questions arise. As we drift away from the enigmatic shadows of the Baltic Sea anomaly, our journey takes us to another maritime marvel, one that has been both feared and revered by sailors for centuries. We're venturing into the realm of maelstroms, the mighty whirlpools of the sea. These swirling vortexes, where two opposing currents meet, have been the stuff of legends, tales of ships and brave sailors being swallowed whole by the ocean's fury. Maelstroms have been etched into our collective consciousness, not just as natural phenomena, but as symbols of nature's raw power and unpredictability. Imagine, if you will, a vast expanse of water suddenly spiraling into a ferocious funnel, its center a void threatening to pull everything into its abyss. Such is the might of a maelstrom. Historical records and maritime lore are replete with tales of these whirlpools. The Vikings, those fearless seafarers, spoke of maelstroms in hushed tones, respecting their power to sink even the sturdiest of longships. These vortexes, with their unpredictable nature, were seen as gateways to the unknown, perhaps even to other realms. But what causes these formidable whirlpools? It's the collision of two opposing currents, creating a rotational force that can be so powerful it's likened to an underwater tornado. And just like their atmospheric counterparts, maelstroms can be both mesmerizing and menacing. Navigating further into the swirling depths of maelstroms, we find ourselves confronted with the very real dangers these whirlpools pose. While their beauty and mystique have been celebrated in tales and legends for sailors and their vessels, maelstroms have often spelled doom. Let's delve into the treacherous waters and understand the perils that these natural phenomena present to ships. Throughout history, countless tales have been told of ships, both large and small, that ventured too close to a maelstrom and were never seen again. The sheer force of these whirlpools can be so overwhelming that even the most robust and well-built ships can find themselves helpless against their pull. The vortex created by the colliding currents can trap a ship, drawing it inexorably towards its center, where the pressures and forces can tear it apart. For smaller vessels, the danger is even more pronounced. The turbulent waters around a maelstrom can create waves that are unpredictable and challenging to navigate. A ship caught off guard can easily be capsized, throwing its crew into the tumultuous waters, where survival becomes a desperate battle against nature's fury. Even in our modern era, with advanced navigation systems and more knowledge about these whirlpools, maelstroms remain a significant hazard. The unpredictability of their occurrence and the rapidity with which they can form means that ships must always be on guard when sailing in areas known for these phenomena. But it's not just the physical danger that maelstroms pose. For sailors of old, these whirlpools were often seen as omens or signs of the displeasure of the gods. The psychological impact of encountering a maelstrom, especially for those unprepared, can be profound. The fear, the awe, the realization of one's insignificance in the face of nature's might, all these emotions can overwhelm even the most seasoned sailor. Sailing onward from the perilous embrace of maelstroms, our journey takes an even deeper, more mysterious turn. We find ourselves on the cusp of a phenomenon that, at first glance, seems to belong more to the realms of outer space than the depths of our oceans. Yet, here in the vast blue, we encounter the enigma of underwater black holes. These phenomena, while not black holes in the astronomical sense, share an uncanny resemblance in their behavior and effects. Underwater black holes, much like their cosmic counterparts, are regions where matter is compacted so densely that nothing can escape their pull. These vortices, spanning up to 93 miles in diameter, are so massive and powerful that they trap everything in their path. And much like the event horizon of a cosmic black hole, once you're caught in the grip of an underwater black hole, escape becomes nearly impossible. But what causes these underwater behemoths? They are the result of powerful ocean currents and the Earth's rotation, creating massive whirlpools that act like vortices. Their sheer size means that they often go unnoticed, even by professionals, as their boundaries can be hard to discern. For ships and marine life, these underwater black holes can pose significant dangers. The force exerted by these vortices can pull a ship under or trap marine creatures, making navigation in such areas a risky endeavor. The swirling waters can also create turbulence and unpredictable wave patterns, further complicating navigation. As we emerge from the depths of underwater black holes and their enigmatic pull, we are greeted by a spectacle of a different kind, one that paints the sky rather than the deep blue sea. We turn our gaze upwards, towards the horizon, where the sun meets the sea in a dance of colors. Here, in this fleeting moment of twilight, we encounter the mesmerizing marvel known as the green flash. The green flash, a phenomenon as elusive as it is beautiful, is a sight that many have heard of but few have witnessed. As the sun dips below the horizon for a brief second or two, its upper edge takes on a brilliant shade of emerald. This fleeting spectacle is not a figment of imagination, but an optical wonder brought about by the refraction of sunlight in the Earth's atmosphere. But what causes this captivating display? The phenomenon occurs when the atmosphere acts as a prism, separating the sun's light into various colors. As the sun sets, the red and orange hues are the first to disappear below the horizon, leaving behind the shorter wavelengths of blue and green. However, the blue light is scattered away by the atmosphere, allowing the green to dominate for that brief moment, creating the famed green flash. For the best chance to witness this phenomenon, one must seek a clear day with an unobstructed view of the horizon, free from clouds or haze. Places with a vast expanse of ocean, like a serene beach or a high cliff overlooking the sea, offer the best vantage points. From the ethereal beauty of the green flash, our journey now takes a more somber turn, bringing us back to the shores and waters that hold both wonder and warning. As we approach the coastlines of Florida, we are met with a phenomenon that, while captivating in its appearance, carries with it a cautionary tale. We are about to delve into the world of red tides and the dangers they pose. Red tides, also known as harmful algal blooms, paint the waters of Florida with a deep, rusty hue. At first glance, this transformation of the ocean might seem like a natural artwork, a canvas painted by nature itself. However, beneath this reddish facade lies a more sinister reality. These tides are caused by the rapid proliferation of microscopic algae, primarily Karenia brevis, which release toxins harmful to marine life and humans alike. The dangers of red tides are manifold. For marine ecosystems, the toxins produced by these algae can be lethal. Fish, turtles, and even larger marine mammals like dolphins can succumb to the toxic effects, leading to mass die-offs. The sight of beaches littered with the lifeless bodies of marine creatures is a heart-wrenching testament to the potency of these tides. For humans, the dangers are no less severe. The toxins released by the algae can become aerosolized, carried by the wind to coastal communities. Inhaling these toxins can lead to respiratory issues, especially in individuals with pre-existing conditions like asthma. Moreover, consuming shellfish contaminated by red tide toxins can result in neurotoxic shellfish poisoning, a condition that can cause severe gastrointestinal and neurological symptoms. The occurrence of red tides, while natural, has been exacerbated by human activities. Pollution, especially nutrient runoff from agriculture, can fuel the growth of these harmful algae, turning sporadic events into more frequent and prolonged episodes. From the rust-hued waters of Florida's red tides, we now journey to the depths of the ocean floor, where fiery giants lie dormant, waiting for their moment to awaken. These are not your typical land-based volcanoes that tower majestically over landscapes. Instead, they are hidden beneath the waves, often miles below the surface. We are about to explore the enigmatic world of submarine volcanoes and the unique behaviors that set them apart. Submarine volcanoes, or seamounts as they are sometimes called, are a testament to the Earth's ever-evolving geology. These underwater mountains are formed when magma from the Earth's mantle rises through the oceanic crust, erupting onto the seafloor. Given their hidden nature, they often go unnoticed until they display a burst of activity, reminding us of their presence. One of the most fascinating aspects of submarine volcanoes is the way they erupt. Unlike their terrestrial counterparts, the immense pressure of the deep ocean affects the way magma behaves. When these volcanoes erupt, they often release a unique form of lava known as pillow lava. As the molten rock emerges, it is rapidly cooled by the surrounding seawater, forming bulbous pillow-like structures on the seafloor. But the intrigue doesn't end there. Submarine volcanoes play a crucial role in nurturing marine life. The minerals and nutrients they release during eruptions provide sustenance for a plethora of marine organisms. Over time, these volcanic sites can become thriving ecosystems, teeming with life, from tiny microbes to larger marine creatures. However, their eruptions can also pose risks. The sudden release of hot magma can lead to the formation of hydrothermal vents, spewing superheated water and chemicals into the surrounding ocean. These vents can create localized zones of extreme temperatures, which can be harmful to marine life unaccustomed to such conditions. Venturing forth from the fiery realms of submarine volcanoes, we find ourselves on solid ground, yet not as stable as one might think. The earth beneath our feet, though seemingly steadfast, is in a constant state of motion, governed by forces that often elude our immediate perception. It's here, on this ever-shifting terrain, that we delve into a phenomenon that has both fascinated and frightened humanity for millennia: earthquakes. More specifically, we'll explore the subtle and not-so-subtle signs that hint at these impending seismic events. Earthquakes, the violent shaking of the Earth's surface, are the result of tectonic plates moving and colliding deep beneath us. While their occurrence is a natural part of the Earth's geological processes, their unpredictability has made them a subject of intense study and concern. For centuries, humans have sought ways to predict these tremors, to find some warning, however brief, that might help mitigate their devastating effects. Over the years, scientists and researchers have identified certain signs that might indicate an impending earthquake. These signs, while not definitive, provide valuable insights into the complex interplay of forces that lead to seismic events. From changes in groundwater levels to unusual animal behavior, these precursors offer a glimpse into the Earth's intricate dance of pressure, movement, and release. As we tread deeper into the realm of seismic precursors, we find ourselves amidst the vast tapestry of nature, where every creature, from the tiniest insect to the grandest of mammals, plays a role in the Earth's intricate symphony. It's here, in the behavior of animals, that we find some of the most intriguing and enigmatic signs of impending earthquakes. For centuries, tales have been told of animals displaying unusual behaviors before the ground shakes, leading many to wonder, do they possess a sixth sense that allows them to anticipate these tremors? From ancient times, there have been accounts of dogs barking incessantly, cats hiding, and birds taking flight en masse just before an earthquake strikes. In more recent times, reports of fish leaping out of water, cows refusing to enter their barns, or snakes emerging from their burrows in the dead of winter have added to the lore. Such behaviors, while anecdotal, have been observed across various cultures and regions, suggesting a pattern that's hard to dismiss. Scientifically, the idea that animals can sense earthquakes before humans do is still a topic of debate and research. Some theories suggest that animals might be sensitive to vibrations or low-frequency sounds, infrasound, that precede an earthquake. Others believe that animals might detect changes in the Earth's electromagnetic field, or even the release of gases from underground fractures. While the exact mechanism remains elusive, what's undeniable is the myriad accounts of animals acting out of the ordinary before seismic events. These observations have led some communities to regard their animals as natural warning systems, paying close attention to any deviation from their usual behavior. Journeying further into the enigmatic world of earthquakes, we transition from the subtle cues of the animal kingdom to a phenomenon that is both visually striking and deeply mysterious. As the ground trembles and the world around us shakes, the skies above can sometimes come alive with an ethereal display, the phenomenon known as earthquake lights. These luminous events, often described as ghostly glows or radiant beams, have intrigued and mystified observers for centuries, adding another layer of wonder to the already complex tapestry of seismic activity. Earthquake lights manifest in various forms. Some witnesses describe them as bright white-blue flashes that resemble lightning, but without the accompanying thunder. Others report seeing orbs of light floating just above the ground, or radiant beams shooting up into the sky. These illuminations, which can last several seconds to minutes, often appear before, during, or after seismic activity. The exact cause of earthquake lights remains a topic of scientific investigation. One prevailing theory suggests that these lights result from the electrical properties of certain rocks. When subjected to intense stress, as happens during an earthquake, these rocks can generate electrical charges. When these charges reach the Earth's surface, they ionize the air, producing the mysterious glows we recognize as earthquake lights. Historical accounts of this phenomenon are abundant. From ancient Rome to 20th century Japan, tales of luminous skies accompanying earthquakes have been documented. In some cultures, these lights were seen as omens or divine messages, while in others, they were regarded as natural, albeit poorly understood, phenomena. From the luminous wonders of the skies during seismic events, our journey now brings us closer to the ground, to the often overlooked world of insects and bees. These tiny creatures, with their intricate behaviors and keen senses, have long been observed to act in peculiar ways before the onset of storms. Their actions, subtle yet telling, provide a fascinating glimpse into nature's interconnected web and the ways in which even the smallest of beings can serve as barometers of impending atmospheric changes. Insects, with their highly sensitive antennae, are adept at detecting minute changes in humidity, temperature, and air pressure, all of which can indicate an approaching storm. For instance, ants are often observed building their mounds higher or sealing their entrances before rain. This behavior is believed to be a protective measure against flooding, ensuring the safety of the colony. Bees, those industrious pollinators, also display behaviors indicative of an impending storm. On a typical day, bees are active, buzzing from flower to flower in their quest for nectar. However, as a storm approaches, there's a noticeable decline in their activity. The hive becomes a hub of activity as bees rush to store food and secure their home. Their keen sense of atmospheric changes, possibly combined with their ability to detect low-frequency sounds produced by distant thunder, prompts them to seek shelter. Similarly, other insects like dragonflies and butterflies, which are typically seen flying high on a sunny day, can be observed flying closer to the ground or seeking shelter under leaves and branches when a storm is on the horizon. While the exact mechanisms through which insects and bees predict storms are still being studied, what's undeniable is their uncanny ability to sense and respond to environmental cues. Their behaviors, often taken for granted or overlooked, offer valuable insights into the rhythms of nature and the delicate balance that exists between all living beings. Navigating from the microcosm of insects and bees, we now set our sights on the vast expanse of the ocean, where waves tell tales of the forces at play, both above and beneath the surface. While most of us are familiar with the rhythmic ebb and flow of ocean waves, there exists a phenomenon that defies this norm, presenting a spectacle as mesmerizing as it is menacing. We are about to dive into the world of square waves and the dangers they harbor. Square waves, also known as cross seas, paint a unique picture on the ocean's canvas. At a glance, the sea appears to be checkered, with waves running at perpendicular angles to each other. This grid-like pattern, while visually striking, is a sign of powerful currents colliding. It occurs when two wave systems travel across each other, usually as a result of shifting wind directions. To the casual observer, square waves might seem like a mere curiosity, a quirk of nature to be admired from a distance. However, for sailors and anyone venturing into these waters, they pose significant dangers. The intersecting waves create powerful riptides and strong undercurrents, making navigation treacherous. Boats and ships can be caught off guard by the unpredictable movement of the water, increasing the risk of capsizing. Furthermore, for swimmers, these waters can be particularly perilous. The force of the colliding waves can pull one under swiftly, making it challenging to resurface. The turbulence and undertow created by square waves can disorient even the most experienced swimmers. While square waves are a testament to the ocean's ever-changing moods and the intricate dance of wind and water, they also serve as a stark reminder of the respect and caution the sea demands. Nature, in all its beauty and fury, constantly challenges our understanding and pushes us to be ever vigilant. From the mesmerizing patterns of square waves, we are drawn back to the quieter yet equally potent manifestations of the ocean's dynamics. Beneath the shimmering surface, a phenomenon unfolds that, while beautiful, carries with it implications that ripple across ecosystems and human communities alike. We're about to delve into the world of algal blooms and the multifaceted dangers they present. Algal blooms, often recognized by their vibrant hues that paint vast stretches of water, are rapid increases in the population of algae in freshwater or marine water systems. While some of these blooms are harmless, others, known as harmful algal blooms, HABs, produce toxins that can have devastating effects on marine life, the environment, and even humans. The dangers of HABs are manifold. For marine ecosystems, the toxins released by certain algae can be lethal. Fish, shellfish, and larger marine mammals can succumb to these toxins, leading to significant die-offs. The sight of shores lined with the lifeless bodies of marine creatures serves as a grim testament to the potency of these blooms. For humans, the risks are equally concerning. Consuming seafood contaminated by algal toxins can lead to serious health issues. ranging from gastrointestinal problems to neurological disorders. Moreover, the toxins from some algal blooms can become aerosolized, posing respiratory risks to those living near affected areas. But the dangers don't end there. As these blooms decay, they consume vast amounts of oxygen, leading to hypoxic conditions or dead zones where most marine life cannot survive. This not only disrupts the marine food chain, but also impacts local economies that rely on fishing and tourism. The rise in the frequency and intensity of HABs in recent years has been linked to various factors, including increased nutrient runoff from agriculture, rising water temperatures, and changing oceanic conditions. These factors, often exacerbated by human activities, underscore the intricate relationship between our actions and the health of our oceans. Transitioning from the silent yet potent dangers lurking beneath the water's surface, our attention is now drawn to the vast expanse of the sky, where nature's power manifests in colossal swirling systems. These systems, with their immense scale and energy, have the potential to reshape landscapes and alter the course of communities. We are about to explore the early signs of one of nature's most formidable phenomena, the hurricane. Hurricanes, known by various names across the globe, from typhoons to cyclones, are intense tropical storms that form over warm ocean waters. Their formation and intensification are influenced by a combination of atmospheric conditions, sea surface temperatures, and wind patterns. Recognizing the early signs of an approaching hurricane can be crucial for preparedness and safety. Cloud patterns. One of the earliest indicators is a change in cloud patterns. As a hurricane develops, it often forms a distinctive circular shape with a clear, calm eye at its center. Satellite imagery can capture these formations even when they're still days away from land. Swells and waves. The ocean often provides early warnings. Large swells, generated by the distant storm, can reach shores days before the hurricane makes landfall. These swells can be accompanied by powerful, unpredictable waves. Changes in wind. As a hurricane approaches, there's a noticeable shift in wind patterns. Winds may become stronger, more consistent in direction, and carry a damp, warm feel. Barometric pressure. A significant drop in barometric pressure is a telltale sign of an approaching storm. Hurricanes have very low central pressures, and as they near, this drop can be detected by barometers. Heavy rainfall. Intense and prolonged rainfall, often in bands, can precede the hurricane's center. These rain bands can lead to localized flooding even before the main storm hits. Wildlife behavior. Just as with earthquakes, animals can often sense changes in the environment before humans do. Birds might fly inland, and other animals may display signs of restlessness or seek shelter. Sky and sunsets. The sky can take on a yellowish golden hue, and sunsets might appear more vivid and red due to the scattering of light by the increased moisture and particles in the air. Being aware of these early signs is essential, but it's equally crucial to stay informed through official channels. Meteorological agencies monitor hurricanes closely and provide regular updates, forecasts, and warnings. From the subtle early signs that hint at the approach of a hurricane, we now delve deeper into the storm's progression, tracing its path as it draws ever closer to the shore. These colossal weather systems, with their swirling winds and torrential rains, undergo a series of transformations as they interact with land, each phase bringing its own set of challenges and dangers. Let's journey into the heart of the storm and understand the progression of a hurricane as it nears and eventually meets the land. Strengthening over warm waters. As hurricanes traverse the warm ocean waters, they draw energy from the heat, often intensifying in strength. The warmer the water, the more fuel the hurricane has to grow in size and power. Formation of the eye wall. The most destructive part of the hurricane is the eye wall, a towering ring of thunderstorms that surrounds the calm eye. Here, the winds are at their strongest, and the rainfall is most intense. Storm surge. As the hurricane approaches shallow waters near the coast, its powerful winds push a massive wall of seawater towards the shore. This storm surge can elevate sea levels by several feet, leading to significant coastal flooding, especially during high tide. Landfall. This is the point when the hurricane's eye moves over land. It's often accompanied by a temporary lull in wind and rain, but this can be deceiving. Once the eye passes, the winds shift direction and quickly return to their previous intensity. Interaction with land. As the hurricane moves inland, it encounters friction from the terrain, which can slow its winds. However, the rainfall often continues, leading to potential freshwater flooding, especially in areas with poor drainage or already saturated ground. Loss of warm water fuel. Without the warm ocean waters to sustain it, the hurricane begins to weaken. However, even a weakening hurricane can bring torrential rains further inland, posing flood risks to areas far from the coast. Transformation into a tropical storm. As the hurricane loses its strength, it's downgraded to a tropical storm. While less intense than a hurricane, tropical storms can still bring heavy rainfall and gusty winds. Dissipation. Eventually, the storm system disperses, leaving behind a trail of destruction, but also much-needed rainfall to some regions. The remnants of the hurricane can continue to cause weather disturbances even as they break apart. The progression of a hurricane from its formation to its eventual dissipation is a testament to the dynamic forces of nature. These storms, while destructive, are also a crucial part of our planet's atmospheric system. Moving from the swirling tempests of hurricanes, our journey now takes us to a landscape where the Earth's inner fervor manifests itself in dramatic fashion. Here, amidst rugged terrains and often under a plume of smoke and ash, stands the majestic and awe-inspiring image of a volcano. A volcano is not just a mountain, it's a portal to the Earth's fiery core. It's where molten rock, ash, and gases escape from beneath the crust, painting a vivid picture of the planet's dynamic inner workings. The very sight of a volcano, with its imposing silhouette against the skyline, evokes a mix of reverence and trepidation. The image of a volcano, often crowned with a smoky plume, serves as a reminder of the Earth's ever-evolving nature. Beneath its surface, magma chambers fill and pressure builds until it finds a way out, either through a dramatic explosive eruption or a slow oozing flow. The lava, as it cascades down the slopes, solidifies and adds new layers to the volcano's structure, making it a living testament to the Earth's continuous process of creation and destruction. But a volcano is not just about fiery eruptions and molten rock. It's also about the ecosystems that thrive on its slopes, the fertile soils it enriches with minerals, and the cultures and communities that have revered and lived alongside them for millennia. For many, a volcano is both a deity and a demon, a giver of life and a harbinger of destruction. From the majestic silhouette of a single volcano, our perspective now broadens to encompass the global stage, where the eruptions of these fiery giants can have ramifications that ripple across continents and climates. Volcanic eruptions, while localized in their immediate impact, can influence environments, weather patterns, and even societies far removed from the eruption site. Volcanic eruptions release vast amounts of ash, gases, and aerosols into the atmosphere. This cocktail of particles can have a profound effect on our planet's climate. For instance, sulfur dioxide, when released into the stratosphere, can combine with water vapor to form sulfate aerosols. These aerosols reflect sunlight back into space, leading to a temporary cooling effect on the Earth's surface. Historically, significant volcanic eruptions have been linked to cooler global temperatures, sometimes lasting for several years. Beyond the climatic effects, the ash from volcanic eruptions can have far-reaching consequences. Carried by wind currents, fine volcanic ash can travel thousands of miles from its source. This ash can pose hazards to aviation, as it can damage aircraft engines and reduce visibility. On the ground, ashfall can contaminate water sources, damage infrastructure, and harm agricultural lands, affecting food production and local economies. The gases released during eruptions, particularly carbon dioxide, also play a role in the broader context of global climate change. While volcanoes contribute a fraction of the CO2 emissions compared to human activities, they are a natural source of this greenhouse gas and have played a role in shaping the Earth's climate over geological timescales. Furthermore, volcanic eruptions can influence global trade and travel. Disrupted flight paths due to ash clouds, damaged infrastructure, and affected agricultural outputs can have economic implications that resonate across countries and continents. Yet, for all their potential for destruction, volcanic eruptions also play a vital role in the Earth's natural processes. They replenish the soil with nutrients, create new landforms, and contribute to the carbon and nutrient cycles. From understanding the far-reaching impacts of volcanic eruptions, we now zoom in, casting our gaze upwards to the billowing plumes that rise majestically from an erupting volcano. These aren't mere clouds of smoke, they are complex mixtures, carrying within them the essence of the Earth's interior. Let's delve into the intricate composition of volcanic clouds and uncover the secrets they hold. Volcanic clouds, often referred to as eruption columns or plumes, are a captivating sight, but they are also a cocktail of various elements and compounds. At their core, they are composed of ash, gases, and aerosols, each with its own story to tell. Ash. The most visible component of a volcanic cloud is ash. These are tiny fragments of rock and glass, pulverized during the eruption. The size of these particles can vary, with some being as fine as flour and others much larger. This ash can be carried by winds for thousands of miles, affecting areas far from the volcano. Gases. Intermingled with the ash are various gases that have escaped from the magma. The most abundant of these is water vapor. However, volcanic clouds also contain significant amounts of carbon dioxide, CO2, sulfur dioxide, SO2, and hydrogen sulfide, H2S, among others. Each of these gases can have different environmental impacts, with sulfur dioxide in particular playing a role in climate cooling when it forms sulfate aerosols in the atmosphere. Aerosols. These are tiny droplets or particles suspended in the cloud. In the case of volcanic clouds, the primary aerosols are sulfate aerosols formed from the reaction of sulfur dioxide with water vapor. These aerosols can reflect sunlight, leading to a cooling effect on the Earth's surface. Volcanic rocks and minerals. Larger eruptions can also thrust bigger rock fragments and minerals into the air. These can include pumice, a light and porous volcanic rock, and various minerals that provide insights into the composition of the Earth's mantle and crust. The composition of volcanic clouds can vary based on the nature of the eruption and the type of volcano. For instance, volcanoes that erupt more explosively, like those in the Pacific Ring of Fire, tend to produce clouds richer in ash and sulfur dioxide compared to the more effusive eruptions seen in places like Hawaii. Transitioning from the composition of volcanic clouds, we now journey deeper, tracing the path of magma as it moves from the Earth's fiery depths to the surface. This ascent is not sudden. It's a culmination of various stages, each marked by distinct signs and processes. Understanding the stages leading up to a volcanic eruption provides a glimpse into the intricate dance of geological forces that culminate in one of nature's most spectacular displays. Beneath the Earth's crust, in the molten mantle, pockets of magma form. This magma, being less dense than the surrounding rock, begins its slow ascent towards the surface. As it rises, it may encounter groundwater or other sources of water, leading to an increase in pressure due to the production of steam. This pressure builds up, setting the stage for a potential eruption. The first signs of an impending eruption might be subtle. The ground around the volcano may begin to swell or deform as the magma chamber fills and expands. This deformation can be detected using modern instruments, providing an early warning sign of volcanic activity. Simultaneously, as the magma nears the surface, it releases gases trapped within it. These gases, including water vapor, carbon dioxide, and sulfur dioxide, can seep out of the ground, sometimes leading to the formation of fumaroles or vents that release steam and gas. The presence of these gases can sometimes be detected by a distinct sulfuric smell in the vicinity of the volcano. Seismic activity is another key indicator. As magma forces its way through cracks and fissures in the rock, it causes small earthquakes, known as volcanic tremors. The frequency and intensity of these tremors can provide valuable insights into the movement of magma and the likelihood of an eruption. As the pressure continues to build, the volcano might exhibit more pronounced signs. Small eruptions, known as phreatic eruptions, can occur, releasing steam, ash, and gases. These are often a precursor to more significant eruptions. Finally, when the pressure becomes too great for the Earth's crust to contain, the volcano erupts. The nature of the eruption, whether explosive or effusive, depends on the composition of the magma and the amount of gas it contains. Drawing from our understanding of the intricate stages leading up to a volcanic eruption, we now turn our attention to the vigilant guardians of these fiery mountains, the scientists. Their role in monitoring volcanoes is a blend of dedication, expertise, and innovation, ensuring that communities near these geological giants are forewarned and informed. Let's delve into the pivotal role these experts play in the dance between humanity and nature's most explosive wonders. Volcanologists, the scientists specialized in studying volcanoes, are the sentinels of these dynamic landscapes. Through a combination of fieldwork, technology, and analysis, they strive to unravel the mysteries of volcanic activity and predict potential eruptions. Their work is not just about understanding the Earth's processes, but also about safeguarding lives and livelihoods. One of the primary tools in a volcanologist's arsenal is seismic monitoring. By placing seismographs around a volcano, scientists can detect the tremors and earthquakes that often precede an eruption. These seismic waves provide crucial insights into the movement of magma beneath the surface, allowing experts to gauge the likelihood of an eruption. Beyond seismic activity, volcanologists also monitor the gases emitted by a volcano. Changes in the composition or quantity of these gases can indicate shifts in volcanic activity. For instance, an increase in sulfur dioxide might suggest that magma is nearing the surface. By analyzing these gases, scientists can gain a better understanding of the volcano's internal processes. Ground deformation is another critical aspect of monitoring. Using tools like GPS and satellite imagery, scientists can detect even minor changes in the volcano's shape or the surrounding landscape. Swelling or sinking of the ground can be indicative of magma movement or changes in the underlying pressure. In addition to these monitoring techniques, volcanologists often conduct field studies, collecting rock samples, studying lava flows, and even venturing close to active vents to gather data. This hands-on approach provides invaluable information about the volcano's history, composition, and potential future activity. But the role of these scientists isn't limited to just monitoring and research. They also play a crucial role in public safety. By working closely with local authorities, they help develop evacuation plans, educate communities about volcanic hazards, and provide timely warnings when an eruption is imminent. Building upon our exploration of the intricate dance between the Earth's fiery wonders and the dedicated scientists who monitor them, we arrive at a moment of reflection. Volcanoes, with their majestic presence and explosive power, encapsulate the duality of nature's beauty and danger. As we conclude our journey, let's take a moment to appreciate the profound lessons and awe-inspiring spectacles these geological giants offer. Volcanoes are nature's grand theaters, where the Earth's internal energies are displayed in dramatic fashion. Their silhouettes, often set against pristine skies or starlit nights, evoke a sense of wonder and reverence. The molten lava, as it flows, paints a vivid tapestry of reds and oranges, illuminating the landscape with its fiery glow. And when the eruption subsides, new landforms emerge, reshaping the topography and giving birth to fertile soils that nurture life. Yet within this beauty lies an inherent danger. The same forces that create are also capable of destruction. Eruptions can alter landscapes, devastate ecosystems, and impact human settlements. The ash clouds, while mesmerizing from a distance, can bring challenges to aviation and health. The lava flows, though a sight to behold, can engulf entire communities in their path. But even in their danger, volcanoes teach us valuable lessons. They remind us of the Earth's ever-evolving nature and our place within its vast tapestry. They underscore the importance of respect, preparedness, and understanding in the face of nature's might. And they highlight the delicate balance between harnessing the Earth's resources and preserving its wonders. As we wrap up today's enlightening journey, we're left with a profound sense of wonder and respect for our planet's dynamic forces. From the enigmatic depths of the Baltic Sea to the towering majesty of volcanoes, we've traversed a world filled with mysteries and marvels. We've delved into the dance of square waves, the allure of the green flash at sunset, and the silent warnings of our natural world before calamities strike. These tales remind us of the delicate balance between nature's beauty and its raw power. They underscore the importance of understanding, respecting, and coexisting with the forces that shape our world. As we bid adieu, let's carry forward the lessons and stories, cherishing the wonders of our planet and the ever-evolving knowledge that helps us navigate its complexities. Until next time, stay curious, stay safe, and keep exploring the marvels of our Earth.